So this array can at any time store 8 elements, but end of array is specified as 4. So that means the index of the last element stored in the array is 4. It also means even though you have space for 8 elements in the array, what is called the accessible portion of the array is from index 0 to 4, because that's where the elements are filled up in the array. So I cannot read, say, the element at index 5 or element at index 6 or element at index 7 from this array, because those positions are not filled up. So given this, what we will have to do is, so let us say, let us look at this example scenario here. We have what do you call, like max size to be 4. So this is like in memory. We have memory addresses 100, 104, 108 and all those things, and they increase by 4 because we're going to store integers. Okay, so let us assume I have an array of max size 4, means it can store at most 4 integers, and the starting address of the array is 108. So that's the base address, and array pointer is pointing to that address. Now max size is 4, so I have filled up with 4 elements. We are going to see how to insert and all these things later. Now let us say I want to add another element to this array, and as it is, we cannot add because the max size is 4 and the array index is 0 to 3 is all filled up. So what we need to do is, we need to create a new block of array somewhere else in memory. Okay, and what is the size of that new block of array? Definitely it needs to hold one more element, right? So at least it should have space for 5 elements. So what we'll do is, we'll go ahead and create a new block of memory whose size is double the original size of this previous array. And again, we'll see later in more detail why we double it instead of just incrementing the size of 1, meaning like why can't we just create a new block of array that can hold 5 elements and add that new element that we want to add or insert. We'll see later why that's a performance issue. So instead of just incrementing the size of the array by 1, we'll create a new block of array that will have space that is double the previous size. And when we do that, what we have to do is, so let us say the new block of array is created at starting address 144. So this array pointer has to now point to this 144. But once we make this to point to 144, there's no longer a handle to this 108, the base address of this array. So what we need to do is create another pointer variable called temp array that stores the same base address as this array, so it's 108. And then redirect this array pointer to point to this base address 144. So that means we'll no longer be able to use this array pointer variable to access this base array. We'll need to use this temp array pointer variable to access this base array, and this array pointer is redirected to this one, so we can use this to access this array now. So this is still empty, so what we need to do is copy. Using this temp array, we can access temp array of 0 means 20, temp array of 45, temp array of 1 means 45, temp array of 2 means 12, and so on. So using temp array, we can access these variables, values, and copy those values to this block of memory. And say array of 0 is temp array of 0, means the 20 will be copied here. Then array of 1 is temp array of 1, means the 45 will be copied here, and so on. And then we can now insert our new element that we want to do, insert at index 4. So max size of this block will be 8, and end of array, which was 3 here, will now be incremented and will be now set to 4. So this is what we do to kind of double the size of the array. And this is how we change the size of the list at runtime. So the array pointer is pointing to this block of memory. So this is our list now. This is no longer our list. So as you see, we are not really adding an element to an already filled up array in the same array block of memory. We are creating a new block of memory and we are adding the new element we want. Similarly, if you want to reduce the size of the list, we cannot reduce the size of the list right away on the existing block of memory. We have to create a new block of memory and copy only whatever the number of elements we want. So instead of 4 elements, you want to store only say 3 elements. Then create a block of memory that can hold only 3 elements, copy only the first 3 values to that block of memory, and use that as your new list. So this is how we are going to increase or decrease the size of the list at runtime using an array. Okay. So this is again, remember this, and now we'll go through the code and see more details of this implementation. Okay. Alright, so let us see the details. So this is my list class. So the list class is going to have 3 member variables declared as private. So the array pointer, again going to store the base address of the array. Then max size, storing the maximum, stores the value of the maximum size of the array. And end of array stores the index of the last element in the array. So the constructor for the list, so I pass the size that I want to set up for the array. So I set that max size equals that size. Then create the block of memory. So I say new int max size. So I create a block of memory that can hold that many integers, and assign that base address to this array pointer variable. And initially I set end of array to be -1. So because initially the array is not filled up, so it's all going to be empty. So it's a empty array with no values specified here. So that means so it will be something like this. So end of array will be -1. So end of array is -1 means it's not pointing, it's not storing anything. So so as I say, the index ranging from 0 to end of array is the accessible portion of the array. So end of array is -1 means you cannot really access this array right now because it's empty. It's not filled up with any values. So using this condition, we can even check if the list is empty or not. So in the list class, that's what we're looking at, we can have an isEmpty function that will return true if the list is empty, and otherwise it will return false. So if end of array is -1, we can return true, indicating the list is empty, otherwise we return false. And then you can have another member function called delete list, and that's as simple as clearing this block of memory. We can do that by saying delete empty square bracket and the array pointer name. That will create the list. So let me put back my element. Okay. All right. So any question on this, how to create the list? Okay, good. So let us now move on to the insertion code. So let us say I want to insert an element at a specific index. Okay, so that means I am assuming here we have created the list and filled it up with elements, and we can use this insert at index actually to insert every element that we want to. Okay, so so you can call it as say insert index, pass some value for the index and the data. So think about like this. If this is your current array, the list, let us say I specify insert index to be 6. Now end of array is 4. So the next index where we can really insert should be 5. So I should not be specifying my insert index as 6 or 7. You could specify insert index to be 0, 1, 2, 3, 4. So you can insert 0, 1 at index 0 through end of array plus 1. You cannot insert beyond end of array plus 1, because if I insert at 6 or 7, it will look like this. So if I insert a value here, that means the intermediate positions are not filled up. So we cannot have an array or list that looks like this. So it should be filled up consecutively starting from index 0. So my valid values for insert index ranges anywhere from 0 to to end of array plus 1. Okay, so I can, if I say anywhere from 0 to 4, that means let us say I specify insert index as 2. That means it should be like this. So right now we have 20, 45, 12, 17, 27. So let us say I want to insert at index 2 value, say 30. Then it should be after insertion 20, 45, the 30 should be here, the 12, 17, 27 have to be shifted to the right. So I can say I have inserted data 30 at index 2. So this is how the array should look like after you insert. Wherever the index it is, that new data should be inserted. Or if you want to insert at the end of the list, which is right now that end of the array at index 4, you can insert the new data at the next available index. So why talk about this? So let us say the user by mistake, because this function insert at index is a member function of the list class. So by mistake the user calls the member function on the list object and specifies insert index as 6 or 7, whatever it is, because the user may not know what is the last element or what is the value of end of array basically. So the user by mistake might have passed an invalid value for insert index. So this is called a self-healing code logic, where even if the user enters some wrong value for insert index, your code should be able to fix that problem. So we know from what we just discussed, the valid values of insert index can be anywhere from 0 to only end of array plus 1. So we check in the code itself, if insert index is greater than end of array plus 1, then we can reset the insert index to end of array plus 1. So we are going to assume that if the user passes an invalid value for insert index, we are going to simply insert that new data at the end of the current array or list. Okay, so I'm going to say insert index is going to be 5. So that's one thing. Now assuming you go past that check, the next thing you have to check is the array having space to really accept a new element. If the array does not have space to accept a new element, we cannot insert or add a new element, another element to the array. So how we check if the array is full? Now if the array is full, end of array will be really 7, because it would have some values for these index positions also. So end of array will be 7. And we can check if max size minus 1 is end of array, because if end of array is 7 is same as checking if it is max size minus 1. So that's what I am checking here, if end of array equals max size minus 1. So the other example we went through, that is here the array is already full, max size is 4, end of array is 3, that's the index of the last element. So here you see end of array is same as max size minus 1. So now let us say we want to insert at index 4, the next available or next logical index where we can really insert a new value. So let us go to this figure as reference for the code. So let us say I want to insert at index 4 and the array is full. So end of array is max size minus 1. So this is the time we need to resize the array. That means increase the size of the array, right? So but I still call it as resize instead of saying increase the size, and we'll see the reason for it as we go through the code for this resize function. So still we are in the list class going through the different member functions. So let us look at the other member function called resize. So I call this resize function and pass the new value of the array that I want. So I'm going to resize it to double its current size. So max size is say currently 4, and I want to make it an array of excuse me 8 elements. So I pass 2 times max size. Okay. So let us look at the code for this resize function. So this s will be 2 times max size. So right now the only way we can access this array block of memory is using this array member variable, which is part of the list class. I have a member variable called list, array pointer that has the base address. So what we need to do now is create a temporary array pointer variable that also has this base address. So I can do that by saying int star temp array equals array. So array is currently this 108 having this base address. So that's a pointer variable. So temp array is also a pointer variable. So I can assign the value of temp array to be the value of the array pointer variable. So when I say this int star temp array equals array, temp array will be somewhere stored in memory and its value will also be this 108, the base address. So now what I can do is, now I have two handles to this block of memory. So I can redirect this array pointer variable to some other memory address. So that's what I'm going to do. I'm going to say new int of s. So this x is the new size of the array that I want to create. So I say new int of s and I say I want to store integers in that block of memory. And I assign that address to this array pointer variable, which is a member variable of the list class. So that means it is redirected to whatever the new address is. So let us say it is 144. So array is now going to store this base as a base address, the value 144. So it's no longer going to be 108. So once I do, now here I have just created the new block of memory. I have not yet filled up that block. So that's what I'm going to do now, going through a for loop and basically copy every element from the new block of memory to from the previous block of memory to the new block of memory. So I do that using a for loop. So I have say index to go through that block of memory is 0. Now you see this, I say index less than min of s comma end of array plus 1. Now min is a built-in function in C++. If you include the library files, let me show you the library files that we need to have. I think it's the algorithm header file. So make sure, of course, algorithm header file will be imported in most of the environment that we use, but if not, make sure you include the algorithm header file so that you can use the min function. Okay. So when you include that, we can basically pass two values to the main function and that will return the minimum of the two values. So here I am passing s, that is the new size of the array I want to create, and end of array plus 1. Now why I specify end of array plus 1? Now you see here I say index less than end of array, index less than the minimum of this two. So if you look at this example, end of array is 3, max size is 4. So, and I'm going to pass 2 times max size for s. So s is going to be really 8. 2 times 4 is 8. So end of array is 3, end of array plus 1 is going to be 4, and max size is going to be really 8. So the minimum of 8 and 4 is going to be 4. So index is going to be upmost less than 4. It will go from 0, 1, 2 and 3. Once index becomes 4, 4 less than 4, you will come out of the loop. So index 0, 1, 2, 3 are the values of index that we can run this loop for. Right? So those are the 4 index values, 0, 1, 2, 3. And we will be copying the values from temp array of index, what are the values is, we will assign them to array of index. So array of this index value 0, 1, 2, 3 will be, the values will be temp array of the 0, 1, 2, 3. So that is if end of array plus 1 happens to be the smaller of the two. So here s is 2 times max size 8, end of array plus 1 is 3 plus 1, 4. So we'll go up to index less than end of array plus 1. So that means we'll be copying up to end of array. Now if it is the other way, if s is less than end of array plus 1, then we'll run the loop from index equal to 0, index less than s. and that will happen only if you are shrinking the array. So remember here S is like 2 times max size, so we are increasing, doubling the space. But we can use this logic to even shrink the array and copy only the first few elements of the previous array. So let us say if I want to shrink the array and copy only 3 elements from the previous array to the new block, then I can specify S to be 3. Then the loop will run from index less than minimum of 3 and end of array plus 1 is still 4. So minimum of 3 and 4 is 3. So that means we'll be copying values from index 0, 1 and 2. So that's why I make it more general, so that using this resize function we can even reduce the size of the array if we want at runtime, instead of just being able to increase its size. So this is a better way of, instead of having two functions, one to increase the size of the array and one to decrease the size of the array, we can just combine both the logic together and say minimum of S and end of array plus 1. So depending on what value of S we are passing, we'll be able to either increase or decrease the size of the new block of memory. And once we are done with copying the values, we can now set, so it's still max size is 4 because that's a member variable, so we have to set its value to be S. So that's like 2 times max size, right? So max size will be now 8. Okay, so with this logic we are able to double the size of the array, or basically increase the size of the array. So the array now has these numbers 20, 45, 12 and 17. It still doesn't have our new data that we want to insert. Okay, so let's see how to insert our new data. So to insert our new data, we'll go through a for loop. And let us see, right now in this example I want to insert at index 4, right? So end of array is still 3, we have not changed end of array, only max size has been set to 8, right? Because if you see in this resize function, I have not anywhere changed end of array. I have just changed max size at the end of this function to the new size, which is 8 in this example. So end of array still remains to be 3, right? So we'll run index equals end of array, which is 3. Again, this is a new for loop, which is in this function. So index takes up, index is a local variable within the for loop. So index is 3. And look at this, index greater than equal to insert index. Insert index is 4 and index starts with 3. So is 3 greater than equal to 4? No. So we'll come out of the for loop right away. We'll not go even inside the for loop if we want to insert at the end of the current array, after end of array. So when we come out of the for loop, what we have is array of insert index. So array is now going to store this base, that is 144 of insert index means index 4. So at that index we can now set whatever the data we want to copy, insert value. So if you want to insert say 27, that will be entered there. Now I increment my end of array. So because we have now added one more element to the array, so this is our index of the last element now, index 4. So end of array is still 3 currently. So when I say end of array plus plus, it will be now incremented to 4. Okay. So this is the logic to insert, and what we went through will insert at the end of the current array, right? Now as you notice here, we can have a very simple function here. So I'm showing here you kind of another function insert, that using which we can insert at the end of the current array, right? So I pass the data. So since I'm going to insert at the end of the current array, I don't need to specify insert index, because it's automatically assumed that when you call insert function, you're going to insert at whatever is at the end of the current array, which is similar, equivalent to saying at the end of the current list. So all I have to check is if the array is full currently or not. If the array is currently full, I have to first resize it, which we do here. So this code is same as this. And since I'm going to insert only at the end of the array, I don't need this for loop, which we just saw. We don't need this because we won't even enter to the for loop if you're going to insert at the end of the array. So I can just specify array and this 2 lines of code which I have really combined into one line. Now this is called pre-increment and this is called post-increment. So here I really add the value to the array at insert index and then simply increment end of array, say by 1. Here I don't want to, because I don't have an insert index. The only way I can really insert the data is using the end of array itself. So end of array needs to be first incremented and then you add the value to that index, and that's what I am doing here. And I say end of array needs to be first incremented because end of array is currently 3, so it has to be made to 4 and then you insert the new data at that index. So that's why I do plus plus end of array pre-increment, then array of that new value of end of array equals the data. So the data will be inserted at this index, right? So any
You can
question
do it
on
either
this?
way.
Any question before we proceed?
Are you saying that you can do it either way?
What's that?
You're saying that you can do it either way?
Okay, let me clarify that. Using this insert function that we just saw at the end, we can insert at the end of the array. Now this insert at index can be used to insert at any valid index of the array ranging from 0 to end of array, and we have not yet seen the logic for that. Basically I have not gone through this for loop yet, how we can insert somewhere in the middle of the array. So this is a more generic function. Using this function insert at index, we can insert anywhere in the array starting from index 0 to end of array plus 1. Using this function insert, we can insert only at the end of the array. Okay, is that clear? So still just wait, we'll have to look at how to insert somewhere in the middle of the array, and we are going to go through this for loop in detail now. Okay, is that clear?
Got it.
Okay, so let me stop and save this video.